Hey everybody, Mr. Longo here, and we're going to talk about hyperbolas in this video. By now you should have experienced circles, which are really simple. And then if we pull a circle a little bit, it turns into an ellipse, and that had some more complicated tests to do because you had different radii depending on if you were going in the X or Y direction and stuff like that. So what we're going to cover in this video is another conic section called hyperbolas. And they're going to look like this. They're going to open left and right or up and down. And what determines if they're going to open right or left or up and down is the positive axis. So we have x minus h over rx, which is our radius in the x direction, minus y minus k over ry, which is our radius in the y direction. A lot of times you will see these as a and b's. I sometimes find it easier to just call it, rx and ry, so we know which direction our radius is going, but really it's up to you. Now the other thing we could do is we could start a negative at the beginning and put a plus in the middle. Everything means the same. Those pluses and minuses, though, that determines which direction your hyperbola is going to open. So in this first example, x is positive, so the hyperbolas open in the x-axis direction, left and right. If the first one is negative and your y is positive, then the y is going to be up and down, so this hyperbola is going to open up and down. Now, very similar to ellipses. Your center is still hk, just like an ellipse and a circle. Your rx and ry are your different radii, depending on if you're going in the x or y direction. And c is still the distance to the foci, just like in an ellipse. However, the equation is a little bit different because the distance is going to be farther, and I will explain that in a little bit again. So it's a lot easier to just go graph a few hyperbolas and see what they look like, and that'll help you understand what everything is. So the first thing you should do is kind of list out your information of what you're working with. So our center is still opposite of x, opposite of the y terms. So x plus 2 would give you a negative 2, comma. Y minus 3 would give us a positive 3. So it's still opposites of the insides of the parentheses. Our rx is our radius in our x direction is 3, and the ry is 4. So that's where you need to start. Now this does not look like an ellipse. So if we were to do an ellipse here, we would start at negative 2, 3, and we would put our center. And then our radius in the x direction would be 1, 2, 3 to the right, and 1, 2, 3 to the left. And then our radius in the y direction would be up 4 and down 4. But instead of drawing an ellipse, I want to tell you this is not part of the graph, it just helps you do it. Is you box those 4 points. So you use those 4 points as a box. And that's what we're going to use for our hyperbola. The other thing you want to do is use these the corners to draw diagonals. Don't worry, I'll show you why in a second. Now, it's very important that on a quiz or a test, you do not draw those dashed lines as solid lines. Remember, dashed lines on graphs represent something that's helpful to you but is not necessarily there, like asymptotes. These guys are diagonal asymptotes to help you graph your hyperbola. So here is the actual hyperbola. The actual hyperbola of this graph looks like this. So we have a positive x, so this opens in the x direction. And this right here is the vertex of one of our pieces of the hyperbola. So it will not cross those diagonal asymptotes. And that's what one part of it looks like. And the other part is right here. So that point that we graphed for our rx, since we're opening in the x direction, that's what we're going to do. So again, it'll never touch those asymptotes. And that's just a little sketch. It probably gets a little closer on this one, but these are kind of tough to sketch out, but that's what it looks like. And if you can give me that, you are solid. Now the last thing, though, is our foci. So just like an ellipse, a hyperbola has foci as well. So what we're going to do is find the foci this time. Now remember, the equation is different. It's c squared is equal to rx squared plus ry squared. So c squared is equal to 9 plus 16 is 25. So c is equal to 5. So our distance from the center to the foci is 5 units away. Now, if you remember what I said about ellipses, the foci is always inside of the graph. So 5 units to the right would be 1, 2, 3, 4, 5 units to the right, and 1, 2, 3, 4, 5 units to the left, because you must be inside the graph. Okay, so the coordinates would be 3, 3, and -7, 3. Now here's the thing. If it opens left and right, your foci go left and right. So your y value is not going to change. So this would be -2 plus 5 and -2 minus 5, and that's how you get those answers. So again, you can just graph them first, but if they turn out to be decimals, if it's opening left and right, it's just -2 plus 5, comma 3, and -2 minus 5, comma 3. The x is what's changing because it's opening left and right. Okay? So, here's an example for you. It's the exact same type of question. The only difference is we have some different numbers. So, and you might have to determine which direction, of course, it opens. Hint, hint, this one's different. Pause the video and see if you can list out all of the important information. See if you can sketch this graph. Give it a shot. Click play when you're ready. So the first thing you should have done is listed your center, which would be at 1, 0. So we're right here at 1, 0. The radius in our x direction is 6. The radius in our y direction is 2. So we have 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6 to the left. Radius in the x direction is up 2 and down 2. And that, remember, creates our box. If this was an ellipse, we would just draw an ellipse, but this is not. This is a hyperbola. So we draw a box, dashed lines, of course. Do not give me solid lines. And also draw your horizontal asymptotes, or your diagonal asymptotes, I'm sorry. And now you have the setup. So now you have to determine, does this guy open up or down? Well, since y is the positive direction this time, we have a hyperbola that opens up. Now this one's going to be a lot wider because look at how wide your asymptotes are. So again, they start at the vertex, going in the up and down direction because y is positive, and there's a hyperbola. It's a really wide hyperbola, but it's all right. Last step, finding little c. So we have c squared is equal to 6 squared plus 2 squared. So c squared is equal to 36 plus 4 would be 40. So then c is equal to the square root of 40, also known as 2 root 10. But for graphing purposes, it's really difficult to graph a radical. So what you want to do is just type it in your calculator and say that c is approximately 6.3. You know, if you do the square root of 40, it's going to give you 6.32, but on a graph it's kind of hard to graph little decimal increments, so 6.3 is good enough. So our little c value is 6.3. Now we have to remember our foci are always inside of the graph. So since this graph is going up and down, our foci are going to go up and down, which means we're going to add to the y-coordinate of our center. So for both of these, the x-coordinate is not going to change. So look, you're going up 6.2 from the center. So up 1, 2, 3, 4, 5, 6, and a little bit. And you're going to go down 1, 2, 3, 4, 5, 6, and a little bit to represent your up and down of 6.3. Now those coordinates, of course, would be 0 plus 6.3 and 0 minus 6.3. So in this case, since we're at 0, that's really simple. It's just 6.3 and negative 6.3. Okay, and that's how you graph this hyperbola. So if you got that right, good job. You're ready to rock. One more question in the notes, and that's just working backwards. So it's writing an equation of a hyperbola from a given graph. Well, that should be pretty simple to do if you just set it up and look at your key information. So the first thing you probably want to do is look on the inside and find the center. It's at -5, -2, which means that comes from x plus 5 and y plus 2. Because remember, the center is opposite. Then you have your Rx and your Ry. Your Rx is 2 units to the right. Your Ry is 3 units up. And now you just have to pay attention to your negative. Where does the negative go? Well, this is opening up and down, just like our last example. So remember, hyperbolas always open in the positive direction. So if this is opening up and down, that means your y value is positive, so your x value is negative. All right, and that's how you write the equation of a hyperbola. So that's it for this video on hyperbolas. This is Longo, and I'm out. See you, bye.